Hello everyone, in this video I will be explaining three chemical reactions of alcohols. The first one is dehydration of alcohols, and the second one I'll be explaining how to distinguish between primary, secondary and tertiary alcohols with the help of dehydrogenation reaction and oxidation reaction. Now the first one, the dehydration of alcohols. Now, when alcohols are heated with concentrated sulfuric acid, or when the vapors of an alcohol is passed over heated alumina, it gets dehydrated. That means there is removal of a water molecule. Now here, the nature of the products formed depends upon the reaction conditions, and when we study the relative case of the dehydration of alcohols, our tertiary alcohols would be more dehydrated than secondary than our primary alcohol. Now, since the reaction proceeds via the formation of a carbocation, and we know that a tertiary carbocation is more stable than a primary carbocation, and which is again more stable than tertiary carbocation is more stable than secondary than primary carbocation. Therefore, the order of dehydration of alcohols would proceed by the tertiary would got dehydration more than secondary than primary. Now let's check out the reaction. Now in this reaction, the hydroxyl group and the hydrogen atom attached to the carbon atoms are involved. Now, suppose we take an example here. Let's take our CH3CH2OH. Now, if it is reacted with our concentrated sulfuric acid, we will be getting here CH2 double bond CH2 along with the removal of a water molecule. This is our ethene. Ethene will be formed, and this is our ethanol. Now, this is a primary alcohol. Now, let's check out the mechanism here to check out how the reaction proceeds in the dehydration of alcohols. Now in the first step, it is the protonation of our alcohol. Alcohol is protonated by our acid CH3 CH2RO oxygen atom H plus. Now our alcohol is protonated, and then we'll be getting a CH3 CH. Now, this is our protonated alcohol. Now, in the second step, the protonated elimination, there's elimination of the water molecule in the second step. That is, we have this our H. This is our protonated alcohol. In the second step, water molecule is eliminated. Now that means this water molecule comes out, and then we'll be getting here CH3 CH2 plus H2O. Now this is our ethyl, two carbon atoms, ethyl carbocation. This is a primary carbocation. It is very unstable, therefore reaction. Now, third step, elimination of H plus, and then there is rearrangement with our H, CH2, CH2. Now this comes, and then there's rearrangement, and then we will be getting here our ethene. This is our how the mechanism of dehydration of alcohols takes place. Now, in the formation of this carbocation, we know that a tertiary carbocation is more stable than a primary carbocation, and therefore the dehydration of alcohols will proceed via the order of reactivity would be a tertiary more reactive than secondary than primary. Now for secondary alcohol, let's write an example, CHOH. Now if we take here 85% sulfuric acid is 3BO4 at 440 Kelvin, CH3 CH double bond CH2 along with the removal of water, and then an example of a tertiary alcohol would be this is our tertiary alcohol. Now here, since the reactivity of tertiary alcohol is more, the condition here would be a little H3PO4 at 358 Kelvin, a little lower, and then we'll be getting here our alkene. Okay. Along with our water molecule is removed. Therefore, in dehydration reaction, the mechanism proceeds via the formation of a carbocation, which leads. The first step is the protonation of our alcohol by the acid. The second step is the removal of water, thereby leading to the formation of a carbocation. And in the third step, there is rearrangement of the carbocation, elimination of an H plus, and then a rearrangement leading to the formation of our alkene. Thus, this is the dehydration reaction of alcohols. Now, the second reaction is we'll be studying how to distinguish between primary, secondary, and tertiary alcohols with the help of dehydrogenation reaction and oxidation reaction. Now, the first one, that is our dehydrogenation reaction. In dehydrogenation reaction. Now, here, the reaction in which hydrogen is removed from a molecule of the reactant, it is known as dehydrogenation reaction, means removal of hydrogen. Now, alcohols get dehydrogenated when the vapor is passed over heated copper at around 300 degrees Celsius or 573 Kelvin. Now, let's check out the reaction. Now, when we consider primary, secondary, and tertiary alcohols, primary and secondary alcohols, they get dehydrogenated to easily gives us aldehydes by primary alcohols, and then secondary alcohols gives us ketones. Now, whereas our tertiary alcohols undergo dehydrogenation due to loss of water, and then we'll be getting here an alkene. Now, here the reaction here is that. Now, let's check out how does primary, secondary, and tertiary alcohols gives us the following products. Now, primary, if we take our primary alcohol, CH3, CH2, OH. Let's take our ethyl alcohol, a primary alcohol. IUPAC name is ethanol. Now, at copper, heated copper at 573 Kelvin, our primary alcohols, they will undergo dehydrogenation, means removal of hydrogen H2, and then they will give us our CH3 CHO aldehyde H2. Hydrogen gas is removed, and then we'll be getting here our aldehyde. This is known as ethanol. This is ethanol, our alcohol. This is our primary alcohol. Now, secondary alcohol, secondary alcohol. If we have our secondary alcohol here, secondary alcohol also get dehydrogenated, copper 573 Kelvin, to give us a ketone. Therefore, CH3 CH3 double bond. Oh, this is our ketone with H2. Hydrogen gas is removed. Now, this is our ketone. This is our acetone. Now, this is our secondary alcohol. Now, what happens when a tertiary alcohol, CH3 CH3. Now, CH3. Oh, let's take this side. OH. Now, this is our tertiary alcohol. This is a one. Now, to give us at Cu 573 Kelvin, it will give us an alkene. An alkene along with the removal of water, because tertiary alcohols, they will undergo dehydration due to loss of water. Here we will be getting CH2 CH3 and then H2O. Now, therefore, this is the dehydrogenation reaction of our alcohols. Now, the second reaction, how to distinguish between primary, secondary, and tertiary alcohols. Now, the behavior of primary, secondary, and tertiary alcohols towards oxidation reaction is remarkably different from one another. Thus, this helps us in the identification of the three different alcohols. Now, primary alcohols. Let's check primary alcohols. Now, if we have our CH3, CH2, OH, let's take an ethanol. If undergo oxidation, they get oxidized, undergo oxidation easily to give us an aldehyde containing the same number of carbon atoms attached here, and then again it will undergo second oxidation reaction here easily. Here also the react easily oxidation, they will be oxidized easily to give us an acid. The acid also having the same number of carbon atoms as the alcohol. Thus, a primary alcohol gets easily oxidized to give us an acid. This is our acid. This is the aldehyde. A primary alcohol gets easily oxidized to give us an acid having the same number of carbon atoms as our alcohols. Our alcohol having 2 carbon atoms, acid has also 2 carbon atoms. Now secondary. Now secondary carbon alcohol, let's take our secondary. Secondary alcohol that will undergo oxidation. First oxidation easily to give us here a ketone, and then now the ketone has the same number of carbon atoms as the alcohols. Now it is, if we take this as propan 2-ol, this will give us, it is known as propan 2-on. Now on further oxidation of this ketone, it will be a little difficult. It will be difficult. They will give us a mixture of acids, CH3COOH, each having a lesser number of carbon. Mixture of acid each containing lesser number of carbon atoms than the alcohols as well as the acid. Now, therefore, a secondary alcohol gets oxidized easily to give us a ketone having lesser number of carbon atoms, and then this ketone gets oxidized only under vigorous conditions to form a mixture of carboxylic acids, and both the acids contain lesser number of carbon atoms. Now, a tertiary alcohol. Now, if we take here tertiary alcohol, a tertiary alcohol undergoes oxidation only under very vigorous conditions. It is very difficult only under various conditions to give us here we will be getting our first product. Here would be a ketone and an acid. Now this is our propan 2-on, and then this is our 1 carbon atoms, 1 gram methanoic acid. Now a mixture of ketone and an acid, and both of them containing lesser number of carbon atoms than an alcohol. Now this undergo only, again this will undergo oxidation, very difficult. That means only under very vigorous condition to finally give us an acid. Carbon dioxide and water molecule, and this acid contain lesser number of carbon atoms than alcohol. Therefore, with the help of oxidation and dehydrogenation reaction, the 3 types of alcohols, that is our primary, secondary, and tertiary alcohols, can be differentiated from one another.